Hello friends, welcome to the session on data structure. In this session we will be discussing the different types of queue. In our earlier session already we have discussed what we mean by queue and in what way we can perform the operations such as NQ operation and DQ operation on the queue. As we know, NQ operation will stand for insertion of an element into the queue and DQ operation will stand for deletion of an element into the queue. But as we have seen our earlier session that we have seen only one type of queue where the insertion will take place at the one end and the deletion will take place at the other end. Insertion will take place at the rear end and the deletion will take place at the front end. But as far as this session is concerned, you will find that it is possible that we can form the different types of queues, and accordingly you will also find that we can make the use of these queues in different applications as well. So in this session we will discuss what are the different types of the queues and what are the different applications where actually we can make the use of the queue data structure. So friends, as you know that you are viewing this session on the PSS Central Institute of Vocational Education. I am recording this session for the course of Junior Software Developer. But the students who want to learn computer science or the students who want to learn data structure, they can also make an access to these sessions in order to learn the data structure. So let us start the session and let us understand what are the different types of queue data structure. So as we have seen in our last session that queue is a linear data structure where the elements are stored sequentially one after the other, and the insertion in the queue will take place at the one end and the deletion of the queue will take place at the other end. Normally the insertion will take place at the rear end and the deletion will take place at the front end. And as we have seen that this data structure queue is taken from the real life only, because whenever we go on doing something and if there are large number of people doing the same thing, then normally what is done is that a queue of the people is being formed. So from the same concept, the queue data structure is being taken and it is very effectively used in computer science. So the new element is being inserted at the rear end, sometimes we call it as a back end, and the existing element is being deleted from the front end. So queue is a data structure which is also called as first in first out, FIFO list, because in this case as we know that whatever is the first element that is being inserted into the queue will be moved out or deleted first, and therefore it is being called as a first in and first out list. But in our earlier session we have seen only one type of queue, but actually it is possible that you can form the different types of queue. For example, we can have a circular queue. So circular queue, as its name indicate, it has a shape like a circle. So the linear queue or the earlier queue that we have been discussed can be converted into the circular queue. And when it is possible to convert a linear queue into the circular queue, when we connect the front and rear end of the queue together. So if there is some front end and if there is some rear end, and suppose both the ends are connected together, then in that case you will find that logically a structure is being formed which is similar to like a circle, and therefore such queue is being called as a circular queue. Also it is possible that we can have a double-ended queue. So many times we call this queue as a D queue, and this queue will allow the insertion and deletion at the both ends. As I said you, a queue is a data structure where insertion will take place at one end and deletion will take place at other end. But many times people require both the operations to be performed from both the ends, and if there is such requirement, then in that case we can form a queue which can be called as a D queue, or it is to be called as a double-ended queue. So in the double-ended queue, the insertion and deletion, both of these operations can be performed on both the ends or at both the ends. Many times you will find that we need to set some kind of priority of our service, and this priority can be achieved by forming a priority queue. So there is a third type of the queue which is being called as a priority queue, where each atom has a predefined level of priority. So, we need to assign a predefined level of priority, and those who are having higher priorities will be given access first, and those who are having lower priorities will be given access at end. So, when we assign every element of the queue with some kind of priority level, then that queue is being called as a priority queue. So, these are the three different types of queues that can be constructed by using a simple linear queue: the circular queue, then the double-ended queue, and then the priority queue. Now, let us see in what way we can form these different queues. So, this is a circular queue as shown in this diagram. Suppose we have been given a certain queue which is a linear queue, where the front end of the queue is having the value 10 and its index number is 0. The second element is 20, the third element is 30, the fourth element is 50, and the fifth element is 50. Now, this is the end of the queue, and therefore, the rear is marking to the index number 4. And suppose there are some vacancies in the queue, so that we can insert or we can add some new element into the queue. Now, if I join all these rear end and front end along with their vacancies together, then you will find that a circle structure is being formed as shown in this window. And whenever we form such type of the circle structure, then this queue is being called as a circular queue. And the operations are performed based on the first in first out principle. So, this is the principle that is being used whenever we want to perform different operations on the queue. And this circular queue can also be called as a ring buffer, because it is forming a kind of a circle or it is forming a kind of a ring, and therefore, this queue can be called as a ring buffer. Another queue that is being frequently used by the programmer is the D queue, or sometimes we call it as a deck, or it is also called as a double-ended queue. As shown in this window, suppose this is our linear queue, where we have the front end at this point, where we can have the elements such as 70, 60, 50, 40 in this way, and this is our rear element, and this rear element is having the value 10. Now, as I said, normally in a linear queue we can perform the insertion and deletion not at both the ends, they has to be performed at different ends. But many times in certain applications we require both the operations to be performed on both the ends, and therefore, such a queue is to be formed, and this queue is being called as a double-ended queue. So, here as shown in this figure, we can remove the element from both the ends and we can add the element from both the ends. So, addition of the element from both the ends is possible, removal or deletion of the elements from the both the ends is possible, and whenever we have such type of the queue, then that is to be called as a double-ended queue. So, you can say that double-ended queue is a kind of a hybrid data structure, because actually it is making the use of the data structure called as a stack and the data structure called as a queue. Because whenever we want to form a double-ended queue, then this is possible only when you make a combination of the data structure called hybrid, a data structure called as a stack, and data structure called as a queue. So, when such combination you make the use of, then you will find that we can form the double-ended queue, and therefore, we call it as a hybrid data structure. So, the double-ended queue you can say is like a train station. You must have been observed a train station in the real life, where you will find that on a train station there is some arrangement so that the cars can come in and the cars can go out. So, the cars can come in from both the ends, as well as whenever cars want to move, they can move out from both the ends. So, if such arrangement is there of motion of the cars outside the station, then that is just nothing but a double-ended queue. So, whenever you want to remember a double-ended queue, then probably you can remember the example of a railway station or bus station, where the movement of the car is possible from both the ends. So, whenever we want to implement the double-ended key, then the double-ended queue can be implemented either by using an array or you can implement it by using a linked list. As we have seen in our earlier case of linear queues, that the linear queues can be implemented by using array or they can be implemented by using linked list. In the same way, the double-ended queues can also be implemented by using array or by using linked list. So the scanning of the element in the double-ended queue is actually faster than the conventional queue, because since it is open from both the ends, you will find that we can scan it from both the ends. We can have some input restricted double-ended key, and it is possible that we can have some output restricted double-ended queue. So if you want to add some kind of restriction on the insertion or deletion operation, then that restriction is also possible to add on the D queue. So input restricted DEC will allow the insertion only at the one end and deletion at both the ends. So suppose you want to restrict some insertion operation, then that is also possible, that you can make some restriction on the insertion. Insertion will take place only from one end, and while the deletion, you can allow the deletion from both the ends. It is also possible that you can put some restriction on the deletion as well. That is, as I said, in DQ, the deletion can take place from both the ends. But if you do not want to happen it, then it is possible that you can allow the deletion only from one end and you can allow the insertion from both the ends. So both the way it is possible that you can make it open at both the ends for insertion and deletion, or you can put some restriction on insertion, or you can put some restriction on deletion. Thank you friends for viewing the session. Hopefully you have understood the different types of queues and the applications where the queues are actually used. Thank you all for viewing the session.